Where are we exactly? A simple question for most people. You're sitting at a desk on a computer or watching this on your phone on a bus or something. But that doesn't really tell the whole story, now does it? You're inside a town, inside a country, on a planet called Earth. Well, most of us believe that, anyway.
Flat Earth would be a circular, flat area surrounded by a field that is known as Antarctica.
This white rim around the outside, a lot of people refer to it as the ice wall.
As far as I know, I'm the first guy in the whole world to make a working physical model of the flat Earth. I named this one Hidden Lands Beyond because some of us think that there's other lands that they're hiding from us. They've discovered these other lands and they just don't want us to know about it. I mean, you know, we might want to go there, repopulate it.
I mean, we went.
How do these people believe in this stuff? It's funny because it's something that we've just recently discovered the truth of, historically speaking. It was only around 600 years ago that a guy named Nicolaus Copernicus was trying to figure out why the calendar kept on skipping days through the year. For a very long time, humanity thought that the Earth was in the center of the universe, because it seems kind of intuitive that everything seems to revolve around the place that you're standing, because that's what most of us experience whenever the sun rises and sets. This was the prevailing view for a large period of early history, even coming from guys like Aristotle. Aristotle thought that the Earth was the center of the universe because he didn't think that the stars or the planets or anything that was in the sky was more massive or heavier than the planet. He thought that because gravity pulled heavy objects downwards, the massive objects would collect in the center. So by that logic, the moon and the sun must be lighter than air. The thing about history is that it's continuous. Time moves forward as events lead from one into the other. Aristotle is famous for having one pupil that would define a large portion of Western history, Alexander. It seems like Alexander learned a lot from his master because he was able to go on to win many victories on the battlefield and form one of the largest empires humanity had ever seen, earning him the title Alexander the Great. Unfortunately, he died at the age of 33, and his empire sort of crumbled. But during his lifetime, thanks in part to his conquests, he was able to facilitate the advancement of human science in the quote-unquote civilized Western world, with the foundation of the Library of Alexandria. Ptolemy, sorry, not that one. Yeah, this guy. Ptolemy I Soter. Ptolemy was a major patron of the sciences, and he helped maintain the great Library of Alexandria. It's unfortunate that hundreds of years later it would eventually be burned. The chaos of war doesn't have any mercy. Unfortunately, it seems that Alexander held a lot of it together, and after he died, his empire quickly fractured. Rome was the next one to really seize power, and they didn't last forever either. After the fall of Rome, formal science kind of fell on the back burner. There wasn't really much time to sit around and think about philosophy when you have to worry about the barbarians over the hill. And unfortunately, a lot of the writings that the ancients had made were lost for a long time, but some of them were reclaimed by the Christians, actually.
Tell me honestly, what do you think of these works?
I find them indescribably beautiful.
But they're clearly pagan. Who painted these images? What race of man was ever so glorious that they filled our world with such, as you say, indescribable beauty?
I have been told, sire, that you served at the court of the Emperor Charlemagne, which I have also visited. I cannot imagine, therefore, that you do not know what I know. that these images were painted by the Romans. They conquered these lands a long time ago. They conquered the whole world. But they were pagans. They worshipped false gods.
Never speak of our conversation to any other man here. Nobody else would understand it. They would fear it. They accept an interpretation that a race of giants once lived here. And that we have nothing to do with them. The fact is, Athelstan, we have lost more knowledge than we ever had. These Romans knew things that we will never know. Their pagan gods allowed them to rule the world. What is the lesson that we can learn from that?
Another Ptolemy, strangely enough, helped establish the old Aristotelian model. For a long time, science didn't really advance. The most advanced model, which was Aristotle's, was accepted as true, even if it might not really be that workable. He took Aristotle's model and adapted it in his Almagest. This is how the geocentric model of the solar system and reality was formed. Copernicus tried to understand why Ptolemy's Almagest kept on missing days through the year. It never seemed to really be perfect. It seemed that the only way to fix this model was not for the sun to orbit the Earth, but for the Earth to orbit the sun. And so the Copernican theory of heliocentrism, for sun in the center, was born. Johannes Kepler and Galileo tried to really develop this. Galileo basically was the first practitioner of the scientific method by measuring his surroundings and then forming conclusions from those measurements. A lesson that Newton would learn and use in his quest to develop a working physical system to understand the motion of the planets. Not based on arbitrary cycles, but based on understandable forces, with a mathematical model. The planets aren't pulled along by angels. They're moved by some sort of natural force that we could understand and calculate. The same force that keeps our feet anchored to the surface of the Earth anchors the Earth to the sun and keeps it from flying into space. By using Kepler's model and Galileo's method of measurement and experiment, Isaac was able to finally come up with something that seemed to work in reality. A physical model. Historians often call this the birth of classical physics. Newton was a little bit of an odd fellow, to say the least, but he was very much a product of his time. He tried to unlock the secrets of the universe with every tool available to him, even if this included something like alchemy. Which might seem a bit odd, especially when you consider the fact that he might have been testing his own concoctions, some of which might have contained mercury and other heavy metals. Alchemy was just another tool for Isaac in his eternal search for truth. He had already discovered a large amount with the publication of his Principia Mathematica. This book is basically revolutionary in science for a lot of reasons. For one, it provides the connection between mathematics and science, which is basically just using logic to understand the world. A byproduct of his understanding the motion of the planets was understanding the motion of physical objects in general. He tried to understand exactly how all objects move in nature so that he could understand the motion of the planets. Newton's 3 laws of physics of inertia, force, and reaction have elegantly described almost all motion in nature. But one thing still eluded him: light. For years, he would try to investigate this mysterious phenomenon. Many, up until that point, believed that white light was pure. But Isaac thought a little bit differently than most people. He experimented with prisms and all sorts of equipment and discovered that white light was not pure. Passing light through a prism does not corrupt it. It merely separates it into its components. By proving this, Isaac was able to prove that light wasn't really a mysterious or magical substance. It was physical and could be understood just like anything else. Isaac thought that the light particles were having their paths changed by the prism, and for a long time that held true until a man named Thomas Young performed an experiment known as the double slit experiment, which caused a lot of upheaval because somehow he had proven the impossible. Light seemed to behave like a wave. How would it be possible then that it could travel through space if space was nothing but empty vacuum? A wave needs a medium to travel through, and for a long time scientists tried to discover this medium, known as the luminiferous ether. Unfortunately, with the Michelson-Morley experiment, they proved that this ether doesn't seem to really exist. It would take somebody else to understand this problem,